There's a slight lag on the live here, just to let everyone know. But next, we will have a presentation from Aaron Perez and John Stork from the Materials and Research Division. Go ahead, Aaron.
Welcome, everyone. As Sharon said, my name is Aaron Perez, and I'll be presenting on pipe inspections with my colleague, John Stork. We both work for the North Dakota Department of Transportation as Research and Pavement Design Engineers in Materials and Research section. During this presentation, we plan on going over our pipe inspection equipment, what we have done and found so far with this equipment, the data collection software we are currently using for pipe inspection surveys and inventorying, and what the future program may look like. Our first piece of equipment is the PurePoint P350 crawler. This system is made up of the crawler itself, a powered drum, and a control module. To go over some of the crawler's capabilities, this system is completely waterproof. It is submersible up to 300 feet. The camera is pan, tilt, and zoom capable, and it runs off of electricity. We've primarily used a generator for collection, but there are other options with this. It does have LED lights on the camera as well as an optional light bar, and as you can see on the picture on the left, it really lights up pipes nicely for our inspections. And this is really best suited for isolated pipe inspections as well. Here are two pictures of the movement from the optional elevating arm. This arm allows the camera to be able to center itself in pipes up to 60 inches, depending on the overall configuration. And as you can see from these pictures, we are using double wide tire configurations for a total of 8 tires. And this crawler system really comes with multiple options for tires that can be used on a situational basis for our needs. This system also has a 4-tire cradle, which you can see on the picture in the middle and on the right, which gives the crawler the most height and uses the biggest tires that we have. So to talk about the command module and the powered drum, this crawler is really ran by the command module. The powered drum has a total of 1,000 feet of cable in it, and all information travels through this cable from the camera to the command module. So it's really an all-wired system. And the command module is where you control the crawler using the onboard screen to see what the camera sees, and there are also multiple ways to control the camera through this module. As you can see in the picture on the left, John is using the optional pendant to actually control the crawler while looking at the command module to see what the camera sees. So this is what you would see if you were controlling the crawler. Here's some of the on-screen details. So on the top is the distance counter, and this is actually done by measuring the length of cable that is out of the powered drum. So distance isn't measured by wheel movement, which is very helpful when the tires spin in mud and slick areas to keep that distance actually accurate. Underneath that's the pitch angle, and the camera has a built-in inclinometer, which is used to display this pitch angle. And PurePoint calls the display towards the bottom of the screen the mimic controls, and here's where you can see the relative location of where the camera is, the horizontal orientation of the crawler, and your speed and steering thresholds, whether it's forward, backwards, left, or right. So our second piece of inspection equipment that we have is our Hydraulic Inspection Vehicle Explorer, or HIVE for short. This is our more speedy option and more user-friendly option as well, and consists of a GoPro mounted to an RC car that can all be controlled using an iPad and a controller. We first found out of the HIVE unit from NDDOT. On their website, they have building instructions, parts lists, wiring schematics, anything you can need to assist in putting together the units, along with general information and research that's been done on it. Also, North Dakota LTAP has put together a HIVE, actually before we did. Dale Hageland with NDLTAP let us actually borrow their unit to assist us in putting together our first HIVE. And Dale also gave us all their own parts lists, kept all their receipts and boxes to all the individual pieces, and this helped us out tremendously. So thank you, Dale. LTAP also has information on their website, including a user manual for their HIVE, and if anyone is looking for additional resources. We were invited by Mark Schrader with FHWA and Dale Hageland with NDLTAP to come and see how inspections were being conducted on pipes near Max, North Dakota in 2019 that were of importance to FHWA. And this was the first time we really got to see the HIVE in action, We actually used LTAP's Hive for this inspection, and FHWA was using the Esri Collector app for their documentation and conditioning and location mapping for the pipes under these roads. So go over some of the capabilities of the Hive. We found out this thing is very capable. We've had great success with this unit being able to run in actual really harsh pipe conditions. This thing's waterproof to about 4 inches of water, and we really consider this thing a little monster when it comes to these inspections. It's a pretty cool piece of equipment. So we have found that the Hive to be much more user-friendly compared to the crawler due to its ease of deployment, weight, and overall speed of collection from one pipe to the next, which is why we'd recommend this for like mass pipe inspections. On the picture on the left, John actually deployed the Hive units into the failure area towards the middle of the pipe. This is much easier to accomplish with the Hive as compared to the crawler, just due to weight and size. And with the use of a GoPro camera on the RC car, the picture quality is really superb and makes it quite easy to find issues with the pipes that may not be as easy to spot otherwise. The picture on the right, I really like it. It really shows the quality of the GoPro camera and what you can see inside these pipes. So now I'll get into some of the different inspections we have done that are more focused on the crawler. The first is a pipe along the west ditch of I-29, northbound through Grand Forks on exit 140, and it's right next to a railroad bridge. This pipe is about 140 feet long and ran parallel with the interstate. This pipe was disturbed due to a landslide, and we were asked to go inspect it by our NDDOT geotechnical section. So as you can see, this landslide really messed up the alignment of this pipe. The embankment near the railroad bridge crossing displaced the end section by about 2 feet. And we actually had some serious issues with our equipment traversing this pipe due to the severe separation between the barrels, as you can see. Another location we inspected pipes due to landslide was around Horseshoe Bend. Horseshoe Bend is located near RP 128 on US 85, just north of Long X Bridge and south of Watford City. We inspected 2 pipes requested by our geotech section. One was over 300 feet long and the other was over 500 feet long. And as you can see from the picture on the right, one of these pipes actually became visible from the surface due to the landslide. So we deployed from the inlets of each pipe and really tried to find the best way to set up and maneuver through the landslide material that was very slippery Badlands clay, as you can see from some of the material in these pictures around the pipe inlets and where we set up. So here is a picture from each pipe we inspected. The picture on the left shows our first pipe. This is a concrete pipe that had a large amount of rock and debris in it, and some of these rock were quite large, as you can see from this picture. And the pipe on the right is a smooth wall seamless pipe that pulled apart quite severely due to the landslide. So our next inspection happened in Bismarck near Grand Marsh Bridge. The inlet of this pipe was located in the south ditch of I-94. It traveled downhill at a 2-to-1 slope to River Road, where it then flattened out under River Road and exited directly into the Missouri River. We were asked by Bismarck District to inspect this, as they knew there was already an issue in this pipe, as the ground close to River Road had started to wash away around the pipe. So they just wanted to see how bad the issue was and how much of the pipe actually needed to be replaced or fixed. So we deployed in the south ditch of I-94 in the inlet of the pipe. The outlet at the time was pretty well submerged by water and also partially frozen, which restricted us. And the district came out and removed the large inlet grate in order for us to actually conduct our inspection. So when we deployed, we hit the 2-to-1 slope with ease with our pipe crawler and traversed down the pipe until we hit an issue we really hadn't seen before. Close to where the 2-to-1 ended and the pipe flattened out, we hit foam, as you can see from the pictures. We put our crawler through the foam to see if we could see anything and maybe see if it ended. Instead, we found out it did not end and completely engulfed our crawler, including the camera, and didn't allow our camera to see anything. And we pulled the crawler out. This is how it looked, just like a little cloud on wheels. So we waited a few days and went back out to inspect this pipe once the foam had subsided. And as you can see from the picture, the water traveling down this 2-to-1 right before the pipe flattened out was actually exiting through a hole in the invert of this pipe, flowing around the pipe, causing the washout issue that the district saw. And here I will show a short video of what this actually looked like from the crawler. So now I'll turn it over to John and let him go over the Hive unit more in depth, as well as the collection software and where all these inspections and inventorying will lead to.
All right, first of all, good morning. Thank you all for being here. As Aaron said, my name is John Stork. I work in the Research and Pavement Design section of the DOT's Materials and Research Division. So our goal for this pipe inspection program was to create a program to accurately assess and monitor the condition of our in-place pipe network. So as Materials and Research then, our role was to be a support resource for the districts by developing the framework necessary to move towards the implementation of this project. So a little bit more background on these inspections. The inspections that Aaron was talking about are more of an emergency pipe inspection where typically your failures already occurred, whether it was from a natural event such as a landslide or a storm event, or just a failure from age or deterioration. And then our goal is to assess the extent of the damage and basically provide an in-depth look and aid the designers in figuring out the best course of repair in these situations. So these are typically the most extreme environments we encounter. We usually bring both units, and sometimes we deploy the more robust pier point if the situation calls for it. Sometimes, like Aaron said, we use the smaller unit depending on the situation. So on the other hand, these corridor assessments are typically more of an asset management type routine inspection. These are meant to assess the in-place pipes for replacement on upcoming projects, or simply establish a baseline rating to use for deterioration monitoring and planning purposes for the future. So these assessments, typically we've been doing 10 to 20 mile stretches, and what we found so far, most of them are functional pipes in fair condition. So these assessments are a great tool for finding pipes that we need to replace, but not only that, they're great for finding which pipes we don't need to replace. So to do these assessments, we asked for some district input on upcoming projects or problem stretches of roadway to where we could test our equipment and involve district personnel for training opportunities. The first training we did with the Hive unit itself was in Dickinson District down near Mott on Highway 8 for an upcoming minor rehab. We spent a few days down there with the construction staff doing training on this Hive unit. So the first inspection, we actually did not have the data collection software completed at that point. So it was all paper records. We used RP markers and DMIs or odometers to kind of assign the pipe locations. And then we used the GoPro video numbers and then paper notes. That was a bit challenging just because it was a 15 to 20 mile job with quite a few pipes. But it was a good, valuable thing to see. Just during the implementation of our data collection software, we were able to address some of those issues. We also had a couple equipment issues when we were down there on our first try. We sheared off a couple gears. We ended up upgrading some plastic to metal gears just so we didn't have those issues on future builds. So here's a few of those things that we found on Highway 8. Here you can see there's a pretty significant rust hole from corrosive soil in a corrugated metal steel pipe. This is a good example of a construction installation problem. This is probably from unloading the pipe or from actually installing the pipe. You can see a tear. Another neat thing to note was actually a few weeks after we did our initial training with Dickinson District, they actually utilized the Hive on a full depth reclamation job up near Halliday, North Dakota on Highway 8. So this was encouraging to us just to see the adoption of the new technology so soon after the initial training. In this pipe, you can see some separation of the barrels here, some standing water, slight misalignment. You can see a little bit of cracking here at about 4 o'clock on the haunches. This is another pipe up near Halliday. You can see the end section has separated and caused some void infiltrating soil into the pipe itself. You can see some pretty severe misalignment here. This is a pretty common area where they have some shifting of pipes and some landslides on this stretch. So it was a good tool to get some in-depth look at what was actually going on there. This one actually was a few months later. We spent a few days and a few nights down in Valley City District, down near Ashley on Highway 11. As many of you know, they had a very wet spring, summer, and I guess even fall when we were down there back in 2019. This made some interesting environments for us to run our equipment through, but it also let us test our equipment in some less than ideal situations. So here you can see this is the end section. You have some pretty significant cracking at the crown. You also have some spalling at the joint. The barrel on this one actually looked pretty good, so this would be a good candidate for just an end section replacement. On this one, you can see, so there's a lot of wetlands down in that area of the state. So there's a lot of equalizer pipes, and with high flows comes high sediment, and the water recedes, leaves a bunch of sediment. So here they had about a 50% full pipe of sedimentation. The barrel actually looked pretty good, but this would be a good candidate to mark for cleaning. So this is the typical kind of pipe environment that you'll see in some of these areas. So being as they aren't tied pipes, you have a lot of a little bit of shifting. So you can see at each one of these joints, you have infiltration of soil at each joint, and then you also have pretty muddy conditions. So the problem with pipes like this, when you get these separations, is you have all of this soil coming in and creating a void up here or up top of the pipe, and then you lose your soil support for your flexible pavement up top, and it can't span it, and pretty soon it fails and you have a giant pothole in the road. Valley City has experienced some of these issues on this stretch of roadway, and they were actually pretty hopeful and excited about going and investigating some of the other issues that they've had with other pipes when we left this equipment with them. This is also the first project where we introduced the Survey 123 data collection app. We received some great feedback from the Valley City maintenance staff about the ease of collection and some of the pros of using the digital storage. We collected about 70 pipes here, and you're looking 5 to 10 photos and a video for each one. So you're talking quite a bit of media. So this really helps to keep things straight and collected efficiently. So this is a few months later. This is actually back in November. We were called out. Our geotechnical engineers wanted us to go take a look at a few problem pipes in the Bismarck district down near Selfridge. So we went and took a look at those. Here you can see some pretty significant washout and some scour damage from lack of slope protection there. So this is actually what we found, and we're all too familiar with these dips that are caused by your pipe settlements. And then you can see here on the right, this was actually the same pipe, and you have about 45 inches of standing water that wasn't draining through the pipe. So we actually had a section on the other side here where you had some washouts under the asphalt that it was bridging. So we ended up conveying these results to the Bismarck district back in November, and then that prompted them to do a full centerline pipe inventory on this project for an upcoming sliver widening. So fast forward a few months, this is that same stretch of roadway. We went out and spent a few days with the district staff there, and obviously you can tell it's winter, so that posed some interesting challenges. Anytime you're talking about cold weather and gloves and touchscreens and batteries and electronics, it creates some issues, but overall it went pretty well. It just added a little bit to the collection time. Obviously digging out pipes when you're talking about a few feet of snow takes a little bit of time, or even finding pipes if they didn't have the markers was next to impossible, even if you knew the location of the pipe. Also, the reduced traction in the pipe was kind of an unforeseen circumstance. It's difficult to drive an RC car uphill on ice, so you kind of had to deploy from the upstream end. And then once the weather started warming up, all of this water then had to evacuate through the pipes, and so that put a bit of a delay on us as well. Some pros of the winter collection, obviously it's downtime, so you have more available staffing. Certain pipes that don't ever drain, you can get into them, take a look at the crown while they're frozen over. So you visited all these pipes, now you have all of these photos and videos. What do you do with all of it? You can't just expect people to sift through tens of thousands or hundreds of thousands of photos to actually find out the information that they want. So as Aaron said, we demoed the Esri Collector app with FHWA, and we looked at a couple other software packages. Ultimately, we chose Survey 123 because it fit our needs. It's fairly easy for field collection, and we'll get into that a little bit in a bit, and it's highly customizable for the form. One of the big pros of this is its offline operation. So a lot of these areas you don't actually have cell signal or internet access. So you can actually collect offline. Once you get back online, it will send all of those forms off and upload them to the server for you. So this is actually the Survey 123 data collection app. This is what the inspector would see on their iPad. This is the kind of information that you'll be collecting. So your top is just your general initials, the district at which the pipe is in, highway number. You have a few pipe specific details such as concrete, plastic, size, orientation, all of that. Your inspection date, that autofills when you open the form itself. The video collected, that's simply to filter if you have media associated with the pipe itself. The collect point, so this is actually a geodata location where if I had GPS capability on my computer itself, it would place me at my location that I'm at. Because I don't, it's telling me I'm there. Now this can be used for actually assigning you to an RP along a route. So that's a pretty powerful tool. And then, so you have, then you get into the ranking system. So this is your approach roadway. So like the one on Highway 6 where you have the rutting, you would click yes, and then it'll bring up a series of questions about different distresses along the roadway. And then you assign ratings to that. It automatically prompts you to bring up a camera. If the camera wasn't being used by Microsoft Teams, it would automatically bring it up, and then you simply attach a photo to it and it automatically attaches. You can add comments to that photo, all of this stuff. So it's also worth noting that all of these are conditional statements. So if you click concrete, you'll have different ratings than if you click plastic or steel. And then steel, you have different choices of what type of steel pipe it is. So then you go through all of these conditional ratings. Each one of these actually has somewhat of like a little cheat sheet to it. Now these are all rankings that were derived off the update to the 1986 FHWA culvert inspection manual. So these, I did not just make these up, but they're basically meant to be a reference guide so that we have a standardized inspection and all of our inspectors are on the same page of what good, fair, poor, severe actually mean for each of these respective ratings. So you keep going through all of these. Some of the things at the bottom, pipe require maintenance, we'll get into that a little bit later. That's basically a filtering tool so that we can track that. Some of these, basically, if you click yes, they bring up, most of the time you're not going to have manholes, catch basins, or junction boxes within your pipes. So it'll keep it collapsed just to keep the form a little bit cleaner. Once you're done with the actual inspection itself, you assign an overall condition rating based off of your scale here and the ratings above it. So depending on what you pick, sometimes it'll have you do recommendations. If you pick poor or severe, if you can't find the pipe, let's say it's submerged and you don't know it, you click unknown. That'll also be a filterable thing later. And then you have your associated actions depending on your rating scale. So you can enter those, you can enter your additional comments, you can enter photos, like I said before. You click the camera icon, it brings your photo up, you take your picture, it automatically attaches. There's no backlogging on that. And then it also tags what your photo is. So you're looking at a photo, it'll be tagged north or west surroundings. It's great for knowing what you're actually looking at. You don't have to type a comment if it's attached in that field. And then you sign, you can put your link to your video here, and then you click submit. Once you click submit, it uploads to our server. It actually uploads to Esri's server, and then we pull from Esri's server. So Esri also has a viewer, but theirs requires a license. So we set up our own viewer so that all of our staff can utilize this without needing an Esri license for this. This is actually what you'll see. These are all pipes collected. These are the ones on North Dakota 6 that I was talking about before. So then you can click into the details of it. You see your general details. You see your overall condition, diameter, length, all of that stuff. You can click your additional details and you see all of the defects that were associated on that form. You can see all of your comments, all of your photos are attached at the bottom. So if you want to see, okay, I want to take a look at the approach pavement distress photo. You click that, it brings up your distresses at that location. So it's a really powerful tool of just keeping all of your stuff straight and keeping it organized. Another thing you can do with this is actually the filtering and the query tool. So you can, there's basically limitless options of what you can do with this. But if you go to tools and you go to query, you can actually sort by different areas, different districts if you made a polygon for it, and then you can filter by all of these distresses. So let's say you wanted to see concrete cracking, all of the pipes within the map area that have a poor rating on cracking. So then you go ahead and you click that, and you have all of these 5, and then you can export this however you want to, do whatever you want in Excel. I mean, it's a pretty powerful tool for data observation and utilization there. So the gray ring around here, this is what we were talking about as the needs cleaning. So that's a pretty powerful tool. We'll talk a little bit later, but you could export all of your cleaning locations to, you know, and all of their coordinates even to a report and then hand them off to whoever's doing the work. So that is our viewer. So why are we doing all of this? Well, obviously our #1 goal here is safety. So the goal of this program was to perform these inspections proactively instead of always reactively, to basically get in front of these deteriorations before they become a problem for the traveling public. That's the #1 priority. Now, a lot of these go hand in hand. Your cost savings, obviously, there's a lot of man hours to actually inventory these pipes. But we also save a lot of money in a lot of other ways that are hard to quantify. So take the River Road example that Aaron was talking about. The pipe was basically a heavy flow 2-to-1 on one side, and then it outletted in the river. So there's basically no way to access by either end to take a look at what was actually causing that sinkhole. So within a few hours, the first day, yeah, we couldn't access it. The second day, it took us probably a few hours with the design staff out there to go ahead and take a look at what was causing that defect, and if nothing else, just to give them a location to start digging. Otherwise, you would have to sort of do an exploratory excavation. You'd have to shut down River Road, do some of that stuff. There's a lot more cost and there's a lot more invasiveness to stuff like that. You can also take a look at alternative fixes such as liners. You can see, okay, is this pipe still structurally sound? Can we rehab it instead of always replacing it? You can get a nice look inside of the pipe. You have less downtime, less delay to the public, things like that. You can also save money where you can provide justification that the pipe doesn't need to be replaced just by actually getting an inside look of it instead of just looking from the end sections. Change order is another thing. You can get a better idea of what you're actually dealing with when you bid the project instead of change ordering pipes on for an increased pipe or increased cost later. Ultimately, you're using the information that you're collecting to make the best informed decision about repairing the infrastructure. Oh, sorry. So condition monitoring, that is monitoring our network by the condition, right? So once we get an accurate and full network of our pipes, you can see how they deteriorate over time based off of your rating conditions. And as they deteriorate, you're going to do a more frequent inspection, some of that. Some of these pipes, we basically, by the design manual, you're looking at about 75 years for a center line and about 40 for approaches. So interstate was put in the 50s. Some of the pipes could be nearing some of that. It's all soil dependent as far as their condition. So it's, some of them may well exceed their design life depending on their condition and their surroundings. The maintenance side, we kind of touched on this a little bit. It's the ability to verify in field which pipes need cleaning or maintenance or end sections or any of this, and then being able to export the locations to whoever's doing the work, whether it's in-house staff or contracted or whatever. Post-construction inspections, that's basically just another QC tool to ensure that we get quality construction and the ability to monitor during a potential warranty period for defects in installation or the workmanship. So what's next for us? Well, right now we have a total of 9 of these hives. 3 of them are distributed to the districts already. We plan to distribute the remaining 6 hives throughout the summer and fall. Obviously, this is highly conditional on the COVID-19 situation and the severity of how that impacts the summer season, but we will adapt as necessary with that. So for any of you district personnel in here, if you would like to get involved with this, or if you have a stretch of road that you think would be a good candidate for this, let myself or Aaron know, and we will try to make that happen. So that's all I have for pipe inspections. I think we'll take a question or two. Matt?
Yeah, I got several questions that have come in, so send the first couple to you, John.
Okay.
What happens if one of those pipe units gets stuck?
Sure. So kind of like Aaron, I guess Aaron broke down this. So the big unit is tethered by the data cable itself with 1,000 feet of spool. All of our smaller ones run stainless steel, 250-foot reels, basically. So if your batteries die, if you get it stuck, you flip it, which happens quite frequently. You just reel it back, and you don't lose the equipment. There have been a time where we've lost a light or something in there, and a lot of times you can get them out with a little bit of ingenuity, but it depends. If it's a long pipe, that's just how it goes.
The other question with doing the inspections, and I think maybe Aaron answered this in the chat here, but have you experienced any critters or skunks when you're running the camera through the pipes?
Skunks, no, not yet, thankfully. A lot of poop, a lot of skunk poop, and a lot of skunk scent. So especially during the winter ones, you really kind of just jump in there, and it's a nice cozy little hole for them, and it stinks like skunk. You're very hesitant to jump in there. But no, we found obviously a lot of mice, a lot of frogs, a lot of stuff like that, but not yet. I'm sure we will.
Okay, I got a question for Aaron. Is the intent to inventory all pipes in North Dakota, or will pipe inventories go in conjunction with planned construction projects to aid in design decisions?
I think right away it's going to be to aid in design decisions, but I think the long-term goal is to get everything inventoried, and that's going to be an evolving system of how we do this, and we're just trying to put everything in place to get to that goal. However, I think as of now, we're still in the let's do what we can. If we need something to go investigate, let's go investigate it. But in the end, we would like to get every pipe done and use that map that John kind of showed there. It'd be awesome to be able to sort through, even for the districts, for instance, to look at all your district pipes and, hey, let's look at all the ones that are severe, all colored red. Well, these are the ones we really need to start looking at, so we're hoping this turns into something, evolves into something that will encompass every pipe.
Okay, another question is how do I get an inspection done? Let's say there's a designer out there that's working on a project, or a district that has an interest in getting some of this information. How would you recommend they go about that?
Well, we're hoping we can get a hive unit to every district shortly. So I think that'd be the first start. Get a hold of your own district's hive units, and if it turns into the hive doesn't work for some reason, whether it be because of more than 4 inches of water, or super high grade, or a really long pipe, and it loses connection between the GoPro and the iPad, which we've had really good success with. However, that is possible because it is all wireless in that regard. Then you'd probably want to contact Materials and Research and get a hold of us to get our big PurePoint P350 out there. And that'd be more on a situational basis to get the big guy out there.
Okay. I got a question for John. What's the total cost to build the GoPro crawler, the hive unit?
Well, it ranges. It depends on your needs. So So on the newer ones we've been using, we've done an upgraded GoPro and some upgrades to the actual unit itself just to make it more robust. We've learned some things throughout the process to use a bit higher quality on some of these things. So it's roughly 1,500 per unit, not including the iPad, but it can run on anything the app and the GoPro app, we haven't found a device that it won't run on, Android or Apple.
I think I got one more question we'll squeeze in here is, you're showing that GIS web page. Where do you find that information with all of the pipe inspection information? Yeah,
so right now it's just an internal thing. As far as DOT goes, it's for our GeoCortex. We may be changing that depending, but right now we're still in the implementation phase and the collection phase. So as far as where you can find it, you'll have to, I can post a link, I guess, for all of the internal folks.
I think that was the follow-up question too, is that available outside DOT?
Not at this moment.
Aaron, one more question for you. Pipes that are partially full of water, any plans on how to handle those? How do you typically handle those?
So I'll use the crawler for an example here. Our crawler is 100% waterproof, submersible up to 300 feet. But the issue is if you want to get the camera in water to see any sort of issues, if that water is flowing or if it's murky, that camera is not going to know what to focus on, and there's a good chance you're not going to be able to see anything but a cloud of dirt. So what I would recommend is to obviously want to be able to look at these pipes when they are dry. That'd be the best inspection. But if there are things prevailing, let's say the pipe is half full, and you can look up and see on the pipe, see if it's cracking up on top. The likelihood of being able to see the invert is probably pretty low, but there's always a chance. But that's what we've seen, at least with the big crawler. Trying to get the camera into the water and it doesn't know what to focus on, and you really can't see much. So that would be an issue, I think, no matter what you do, if it's full of water. Unless it's real clear water, I think you're going to have some issues. Any other questions, Matt?
Yeah, I got one more for John. Just to wrap up here, the question was, would you ever bring a lawn chair with you to sit inside that pipe so you can see what's going on? I've seen some pictures of you, tucked in that pipe pretty tight. How does that work for you?
Yeah, a lawn chair wouldn't really fit. It's kind of difficult, and the reason you do that is you have wireless capability and you have your wireless signal from your controller to the Hive itself, and then you have to maintain Bluetooth between the GoPro and the iPad. So and concrete pipes are very good at blocking signal. So sometimes you have to get in there and straddle the stream and sit sideways and control it that way. But no, I have not brought a lawn chair.
All right. Thanks, gentlemen. I think that's all. That covers most of the questions that we got to this point.
Excellent.
Well, thanks, everyone, and thanks for the questions. And I guess in closing, if you have any more questions or want to get in contact with me or John, please feel free to do so, and we'll get you on the right track. Everyone, wash your hands.
And thank you to everyone for attending the first session of the Virtual Construction Project Development Conference. The video from today's presentation will be posted on the conference website. The construction review video will be available on the DOT's YouTube site. Please check the website and look for an invitation to the next session. Thank you for attending.